Hello everyone, welcome to Elixit Academy. Today in this lecture number 2, we are going to discuss about integration by parts and integration by partial fractions. Last week we had discussed about integration by substitution. So today we are going to discuss about the concept of integration by parts and integration by partial fractions. Also we are going to solve few of the specific problems or rather the standard problems which are important for the JEE Mains, Advanced KVPY and BITSAT. So first we start with integration by parts. Now what exactly is integration by parts? Let's see. So u and v are two functions of x. So the integration of the product of these two functions. We are going to find the integration of the product of these two functions. So u and v can be any type of functions. Like it can be uh, a trigonometric function multiplied with a exponential function. Like this, it can be any function. So basically these two are the functions of x. So integration of u into v dx is given by u integration v dx minus integration du by dx into integration v dx whole dx. So here u is the first function, u is the first function and v is the second function. So in words, if I say this is integration of the first function multiplied by the second function is the first function multiplied by the integration of the second function minus integration of now du by dx is the differentiation of the first function. This is the derivative of the first function. Derivative of the first function, that's u, multiplied by integration v dx into dx. So this is the actual formula for integration by parts. Next, we have the IIT rule. What is the IIT rule? Now, we have u and we have v. So u and v are the two functions of x. So now, which one will be the first function and which one will be the second function, we have to decide. So we can only select that which one will be the first function and which one will be the second function. For that, we have to use the IIT rule in order to choose which one will be the first and which one will be the second. So let's discuss about the IIT rule. IIT. Now what is IIT? Here I stands for inverse circular function. Here I stands for inverse circular functions. L stands for logarithmic functions. Now inverse circular function, for example, if I say sine inverse of x, then cos inverse of x, like this. Okay, now next we have L stands for logarithmic functions. A stands for algebraic functions, for example the polynomials. Algebraic functions like x square, x cube, like this. Next we have T stands for trigonometric functions like sine and cos. And lastly we have exponential functions. So for example, now basically depending on this IIT rule, we have to decide which one will be the first function and which one will be the second function. Like which one will be the u and which one will be the v. So like I comes in the first and a comes after that. So I'll take the inverse function as u and then the algebraic function as the v. Let me just take one example. Let me show you with an example. Now suppose we are asked to find the integration of x square into e to the power x dx. Now see here, now which one will be the first function and which one will be the second function? Let's see. Now in the eyelet rule, if you see, we have a is the algebraic function. We have a in the first and we have e at the last. So obviously x square is the algebraic function, so x square will come at the first and e to the power x will come after that. So this is the first function and this is the second function. Like this we have to decide. So this was the basically the eyelet rule, which is a very important in order to calculate or solve the problems of integration by parts. Now let us come to an important result which we have to remember in order to solve the problems. Now this is integration e to the power x multiplied by fx plus f prime of x dx is simply e to the power x fx plus c. Or we can also write like we can just simply multiply this e to the power x with this fx and f prime of x, which is e to the power x fx dx plus integration e to the power x f prime of x dx. This is simply just e to the power x fx plus c. This is a very important result which we have to remember. So now the proof is very easy. You can try out the proof. Like simply just take this function, like this particular function. If we break this function by using integration by parts, some terms will get cancelled and you will be only left with e to the power x into fx. Like obviously the first function will be fx. This will be the first function. E comes at the last, so e will be the last function. So second function, sorry, the second function. E to the power x will be the second function. And using the integration by parts formula, you can simply solve this one. And something will get like this one and the term will get cancelled. You will be only left with e to the power x fx plus c. Okay. So let us start with the problems of integration by parts. Now this problem came in JEE Mains 2019. So let's do this one. So this says that if integration x to the power 5 into e to the power minus 4x cube dx is 1 by 48 e to the power minus 4x cube fx plus c, where c is a constant of the integration, then fx is what? So basically we have to find fx. So the function is, let us write down the function. The function is integration x to the power 5 into e to the power minus 4x cube dx. So let's see how to integrate this one. Obviously we can get some idea that obviously we have to use the integration by parts rule. So let's see. Now this is e to the power minus 4x cube dx. So let's take minus 4x cube as t. First we have to simplify this using the substitution rule. We have to simplify this and then we can easily apply the integration by parts. So minus 4x cube as t. So we are just simply using the substitution. So this is minus 12 into x square dx is dt. So x square dx will be minus dt upon 12. So what will be, so let this be I. So what is I? So we can also write I as, this is x square, alright, x square multiplied by x cube. So this is x to the power 5 multiplied by e to the power minus 4x cube dx. So now x square dx is minus dt upon 12. And from here we can get x cube as, x cube is t by minus 4. x cube was t by minus 4. So we can write this as integration of, so x square dx is minus dt upon 12. This is minus dt upon 12. Now e to the power minus 4 x cube. Okay, we have x cube. X cube is just simply t by minus 4. And we have e to the power minus 4x cube, which is e to the power simply t. So these are just simply constants. So 12 and 4 are constants. So we can take this out of the integration, which is 1 by 48. 1 by 48 into t into e to the power t dt. So now this is very easy to integrate. So simply we have to use the formula for integration by parts. So which one will be the first function and which one will be the second function? Obviously t will be the first function and e to the power t will be the second function by the IIT rule. T is just the algebraic function, so we can keep t as the first function. So 1 by 48. So this we have. Now the first function into integration of e to the power t dt, the second function, minus integration of, now dt by dt is the derivative of t is what? 1. With respect to t, obviously it's 1. And then we have integration e to the power t dt, the whole dt. This is the integration by parts rule. So 1 by 48. Now integration of e to the power t is e to the power t minus integration of, now again integration of e to the power t dt is again e to the power t. Now we have whole dt, so dt again if you have 1 by 48 into t into e to the power t minus, now again integration of e to the power t is again e to the power t plus c. So this is our I. Now let's see what they have asked in the question. They have said this I, this integral, the left hand side equals 1 by 48 into e to the power minus 4x cube fx plus c. So this integral, so I is 1 by 48 into t into e to the power t minus e to the power t plus c. This equals 1 by 48 into e to the power minus 4x cube fx plus c. So we have to find what is fx. So now let's see what is fx. Okay, we have not yet replaced the value of t. T was what? T was minus 4x cube. So we can simply replace the value of t. T was, so we can take e to the power t common and write this as t minus 1 plus c equals 1 by 48 into e to the power minus 4x cube into fx plus c. Now simply replace the value of t. So 1 by 48 multiplied by, now e to the power t is e to the power minus 4x cube, the minus 4x cube minus 1 plus c equals 1 by 48 into e to the power minus 4x cube into minus 4, sorry, this is fx plus c. So now we can compare. We can easily see that fx is minus 4x cube minus 1. Let's see, fx is minus 4x cube minus 1. Option B is the right answer. Now let's move on to the next problem. We have question number 2 says that if integration fx dx is psi of x, then integral of x to the power 5 f of x cube dx is what? So which of the following options is correct? This came in JEE Mains 2013. Let's see. first we take down this integral. We have integration fx dx, and we have this as psi of x. This is psi of x. And what else we have? Integration of, we have to find the value of integration x to the power 5 f of x cube dx. This is psi of x. We have to find the value of integration x to the power 5 f of x cube dx. Let's see. So let us take the substitution x cube as t. We have x to the power 5, so basically we can write this as x square into x cube multiplied by f of x cube dx. Now x cube is t, so 3x square dx is dt. So basically x square, we can easily see that x square dx is dt upon 3. So we have 1 by 3 integration of, now x square, we have x square dx is dt upon 3. We have x cube as t, and then f of t. I just wrote a 1 by 3 two times. So this is dt upon 3. So basically, so 1 by 3 is a constant, you know, so you can simply take this out of the integral and you have t f of t dt. So now what should we do? We have to integrate this using integration by parts. So let's see. So let us take, now what else we have? We have, okay, this was phi of x. This is, there is a printing mistake over here. This is phi of x and not psi of x. Integration of fx dx is phi of x. This is phi of x. So we have integration of fx dx is phi of x. So this is 1 by 3. Now we can simply integrate this by parts. Now which one we shall take with the first function? Let us take this as the first function and this as the second function. So this will be t into integration of the first function ft dt. If you see from here, ft dt will be phi of t. If integration fx dx is phi of x, then obviously integration ft dt will be phi of t. So this is integration ft dt minus integration, the derivative of the first function is 1 multiplied by integration ft dt, the whole dt. So basically we have 1 by 3 multiplied by, now t into integration ft dt is phi of t minus integration, now again integration ft dt. What is ft dt? Is just simply phi of t, phi of t and then dt. So we have these. Now what is the value of t? The t is x cube. So 1 by 3 into x cube into phi of x cube minus integration phi of x cube dt plus c. Now do we have the phi of, now what was phi of t? Phi of t was integration ft dt. Now ft dt, so let's see this one. So basically we can also write this as phi of t dt as 3 into integration phi of x cube into x square dx plus c. So 1 by 3 x cube phi of x cube minus integration x square into phi of x cube dx plus c. So we have this. So this is the 1 by 3 x cube into phi of x cube minus integration x square phi of x cube dx plus c. So this is basically option. So which option is correct? We have x cube, we have phi of x cube, and then 3, 1 by 3 was common for these. 1 by 3 minus integration x square. So this is option, this is option C. Let us move on to the next problem. Now this is a very nice problem. Let's see. Sine of 101x multiplied by sine to the power 99x dx is what? So let's see. Again, we are going to simply use the concept of integration by parts. Integration sine of 101x into sine to the power 99x dx. Let this be I. So I is basically integration. So which one is the first function? Can we take which one? Which one? We should take. Before we take the first function, we have to simplify this further. Otherwise, we won't be able to calculate. Let us write this sine 101x as 100 plus 100x plus x. And the sine to the power 99 is x is just like that. So this is I will be integration. Now we take this as the first function. Let me show you once again. So what we can do, we can break this into sine a plus b. Sine a plus b is sine a cos b plus cos a sine b multiplied by sine to the power 99x dx. So what we can say from here? So I is integration sine to the sine of 100x. Okay, so now let's see here. So we have sine of 100x cos x, and we have sine of 19 sine to the power 99x. So sine of 100x cos x, and we have sine to the power 99 of x dx plus integration cos of 100x multiplied by sine to the power 100x dx sine of 99 sine to the power 99x plus multiplied by sine to the power sine x only is sine to the power 100x. So now let's see. I is, so we have to integrate this function integration by parts. Now that's a huge function. So sine of 100x. Now the question comes over here is which one will be the first part and which one will be the second part. So let us do one thing. So for this type of sums, very carefully see, you have to understand by observation which one will be the first part and which one will be the second part. So let us take this as the first part and let us take this as the second part. So if you take this as the first part and take this as the second part, then this is sine of 100x We are simply going to integrate this by parts. Sine of 100x multiplied by sine of x to the power 100 by 100, integration of the first function, this one, sorry, the second function, this one. We are just simply integrated this one. Integration of the second function is sine x whole to the power 100 by 100. So next we have minus integration. Let's see here. So now the derivative of the first function is what? We can write this as cos 100x into sine x to the power 100. So cos 100x into sine x to the power 100. The derivative of the first function. Okay. The derivative of the first function is sine of 100x is what? Cos 100x. Okay. There was 1 by 100 over here. 1 by 100. So 1 by 100. Not a 1 by 100. Sorry. We are not integrating this. This will be 100. Simply just 100. 100 cos of 100x. And then we have integration by this, so divided by 100. Okay, so basically 100 and 100 gets cancelled. You are only left with cos of 100x multiplied by sine of x to sine of x whole to the power 100 dx, and you have plus integration cos of 100x into sine of x to the power 100 dx. So see here, now what you can get, these two functions get cancelled. These two functions get cancelled. You are left with what? You are simply left with I as integrate as just simply sine of 100x multiplied by sine x to the power 100 divided by 100. So sine x to the power sine x sine 100x, and your option A is the right answer. So 1 by 100 sine 100x multiplied by sine x to sine x whole to the power 100 plus C. Let us move on to the next problem. Here we have integration log of log x plus 1 upon log x. So how to integrate this one? So let's write down integration first. We have log of log x plus 1 over log x and the whole dx. So let us take the substitution first. First we take log x as t. So x is e to the power t. So dx will be what? Dx will be simply e to the power t dt. So basically this is integration. Now log of log x. So we can simply write this what? Now log x is t. Log x was simply t. Log of log x. So log x was simply t. So log of t plus 1 by t. Now dx is e to the power t into dt. So now we have the function what? Now let's see this one. This is e to the power t log t dt plus integration e to the power t into 1 by t dt. So what will be the answer? We can directly say from here. We don't need to calculate this one separately and then we can conclude that. No need to do that. Simply we can conclude this from here in competitive exam I am saying. So if you see this one, I said earlier that integration of e to the power x f prime of x dx plus integration e to the power x fx dx is just simply e to the power x fx plus c. We can see from here what is fx and what is f prime of x. Fx is log t. Let me show you with a different pen. Fx is, this is fx and this is f prime of x. So since the derivative of If fx is log x, then the derivative of log x is simply 1 by x. Here we have ft, so we can write this ft. This is a function of t actually. So we can simply use this formula now, which is e to the power. So what will be the answer? E to the power t into f of x. So we have f of t, so this is log of t plus c. Now we are going to simply replace the value of t. So initially t was log x. So e to the power log x multiplied by log x plus c, and we know that e to the power log x is just simply x log of log x plus c. That's all. Now let us see the last problem of the integration by parts, of the topic integration by parts. Let's see. So we have the integral as integration root over of x square plus 1 multiplied by log of x square plus 1 minus 2 log x divided by x to the power 4 dx. Here x is greater than 0. So let's see this one, how to calculate this one. So we have the integral as integration x square plus 1 into log of x square plus 1 minus 2 log of x divided by x to the power 4 dx. X is greater than 0. Now let's see. So take an x common from here. What happens if we take an x common from here? So x, if we take an x outside of this root, so this will be x, and this is 1 plus 1 by x square, and this is log of x square plus 1 minus, now this can be written as log of x square. 2 log x is also log of x square, is the same thing, and x to the power 4 dx. Now let's see, we have, so what we can do, this is same as uh, now this x, and this is x cube now. Okay, this is x cube. So we have 1 plus 1 by x square whole to the power half. Okay, so log of, now again we have log of 1 plus 1 by x square, and we have 1 by x cube dx. Why this is log of 1 plus 1 by x square? Since log of x square plus 1 minus log of x square is same as log of x square plus 1 divided by x square, and if we further divide this, so this is 1 plus 1 by x square, that's why log of 1 plus 1 by x square multiplied by 1 by x cube. Now we can simply put a substitution, take a substitution. Let's see, we can simply take 1 plus 1 by x square as t. So this is minus 2 by x cube dx is dt. So from here we have 1 by x cube dx is minus half dt. So we have integration t to the power half, we took 1 plus 1 by x square as t, so t to the power half. Now log of, again log of t multiplied by, now we have 1 by x cube is minus half dt, so this is minus half log of t multiplied by t to the power. Now see, we are going to simply evaluate this using integration by parts. So take I late, so log is the first function and algebraic function will come after that. So log will be the first function, so log t multiplied by integration of t to the power half is t to the power 3 by 2 divided by 3 by 2 minus integration of the derivative of log of t is just simply 1 by t multiplied by t to the power 3 by 2, and then we have 3 by 2 here in the denominator, so this is dt. Now let's see, this is minus. Now what we can do, if we further simplify this will be like, you can just simply multiply and all. This is t to the power 3 by 2 log t plus 1 by 3 integration of, now this will be integration t to the power half dt, which is minus of 1 by 3 t to the power 3 by 2 log of t plus 1 by 3 t to the power 3 by 2 divided by 3 by 2 plus c. Now further we can simplify, we can write 1 by 9, this will be 1 by 9, we can take out 1 by 9, and we can also take out t to the power 3 by 2 and write this as 2 minus 3 log t plus c. This is basically how much we can simplify, that's all. We are just simply simplifying this equation. So 1 by 9 into 1 plus 1 by x squared multiplied whole to the power 3 by 2. We are just simply now replacing the value of t. T was basically 1 plus 1 by x squared. So simply if you replace the value of t, and we have 2 minus 3 log of 1 plus 1 by x squared plus c. That's all. This is the answer. Now let us move on to the next part of our lecture. This is integration by partial fraction. Now if I say partial fraction, what do you exactly mean by partial fraction, and why we just use partial fraction? Now if we consider a rational function, suppose fx by gx, or rather if you say a complicated rational function, suppose it can be px plus q divided by x minus a and then x minus b. So this is a complicated rational function, and to break this rational function we can simply use the partial fraction. So to integrate this, so now this is very difficult to integrate just like that. So obviously we have to use some simplification. So that simplification is known as partial fractions. So we are going to represent this in terms of partial fraction, and then we are going to use the integration. So let's see. So let us see, take the first problem. Now here I would like to say that it is not necessary that you have to use integration by parts. Sorry, by partial fraction. It is not necessary to use by partial fractions. Few of the sums which are easy to solve, like by observation you can solve. You can take something common, then you can adjust, and then you can easily solve that. If by observation you can solve that, so in that case it is not necessary to take integration by partial fraction. Using partial fraction you have to integrate, so partial fraction will just take some time. If you use partial fraction, then it will just take some time to solve the problem. But if you can solve this in a more easier way without using the partial fraction, if you can adjust the terms and then write, so it will be easier for you. But in some cases, like where you have huge calculations, it is difficult to use, like it is difficult to observe and write. So basically there we have to use integration by partial fraction. We have to use the process of partial fraction. So let us take the first problem here, what we are discussing. Evaluate the given integral, integration 2x plus 1 divided by x plus 1 multiplied by x minus 2. We have this in the first problem. Now this is the function. Now let's see how we can write this function. We can write this as 2x plus 1 divided by x plus 1 into x minus 2. Now we can write this as a by x plus 1 plus b by x minus 2. So this is now what we have to do. We have to simply find out the value of a and b after comparing the coefficients of x and all, x and the constant part with the left hand side. Let us see. We have to, our main target is to find the value of a and b. Let's see. So a is basically a into x minus 2 plus b into x plus 1 divided by x plus 1 into x minus 2. This is the left hand side, it was 2x plus 1 divided by x plus 1 into x minus 2. Now if you see, we have to compare. Our main target is to find the value of a and b. So 2x plus 1 is a into x minus 2 plus b into x plus 1. Okay. Now we can easily, now there are two processes to solve for a and b. One is the shortcut process you have to use in the exam. Another one is the long cut process. If you are unable to use the shortcut process, then you have to do the, obviously you have to go with the long cut process, but that will consume a lot of time. The long process says that you have to compare the coefficients and solve the two simultaneous equations and then you have to solve, but it will consume a lot of time. You have to solve two simultaneous equations and then you have to find the value of a and b. So we will use a shortcut process. So now let's see. First, let us take the value of x as 2. So this part will be 0. For x equals to 2, we have b into 2 plus 1 equals 2 into 2 plus 1, which is 3b equals to 4 plus 1. So that's 5. So b is 5 by 3. And similarly, make this term 0. So for x equals to minus 1, this will be, so we have minus 1 minus 2 equals 2 into minus 1 plus 1, which is minus 3a equals to minus 2 plus 1 is just simply minus 1. So a is 1 over 3. So we got the value of b, we got the value of a. It just took only few seconds to solve these. So this is the shortcut process. You have to make 1 0, or if there was c into something, you have to even make that term as 0, and then you have to evaluate using this one. So this is comparatively much more easier than the simultaneous equation process. So now what we have to do, we are going to simply replace the value of a and b here in this equation. So this was 2x plus 1 divided by x plus 1 multiplied by x minus 2. Now we are going to simply replace the value of a and b. A was 1 by 3 divided by x plus 1 and b was 5 by 3. 5 by 3 divided by x plus 2. Sorry, this was x minus 2. So 1 by 3 is a constant. So by x plus 1, 5 by 3 into 1 by x minus 2. So this is integration 2x plus 1 divided by x plus 1 into x minus 2 dx. Now this is 1 by 3 integration 1 by x plus 1 dx plus 5 by 3 into integration 1 by x minus 2 dx. Now it is very easy to integrate. This is 1 by 3. The log mod of x plus 1 is 5 by 3 into log mod of x minus 2. Let's see. This is one process of integration by parts. So this is the answer. So let us do one more problem. So this says that integration of x cubed by x to the power 4 plus 3x square plus 2 dx is what? NCRT problem. X cubed by x to the power 4 plus 3x square plus 2 is what? Okay. So let us write down this first. So we have integral of x cubed divided by x to the power 4 plus 3x square plus 2 dx. So this is x. Now let's see. So what we have to do first, we can do one thing. We can take a substitution. We have to, let us take x square st. Okay. Now the numerator is x square into x, that's x cubed, x to the power 4 plus 3x square plus 2 dx. Now if we take the substitution as x square st, so this is 2x dx is dt. So x dx is dt upon 2. Ultimately we have half integration. Now x square, this is t, and x dx is dt upon 2, so half we have already taken out. So we have dt. Now this is t dt. So t by, now x to the power, x square was t, so x to the power 4 was t square. This will be t square plus 3t plus 2 dt. Now what we have to do? We have to first, let us check if we can break this to factors or not. This can be easily factorized. So this is half of integration t divided by t plus 2 multiplied by t plus 1 dt. Now we can easily use the integration uh, by partial fractions. So we can write this as t by t plus 2 multiplied by t plus 1 equals a by t plus 2 plus b by t plus 1. Similarly, you have to again find out. So a into t plus 1 plus b into t plus 2, and here we have on the left hand side we have t. So for t equals to, so first we have to make this 0. So for t equals to minus 1, we have minus 1 equals b into minus 1 plus 2. So this is b is minus 1, and for t equals to minus 2, we have minus 2 equals a multiplied by minus 2 plus 1. So 1 minus 2 is again minus 1. So we have a as 2. Okay. So we have got the value of a as 2 and b as minus 1. So simply we are going to put these values here. So we have the function as, so a by t plus 2 plus b by t plus 1. So integral of t by t plus 2 multiplied by t plus 1 dt is simply integration of uh, a is 2, so 2 by t plus 2 minus 1 by t plus 1. This is minus 1, so minus 1 by t plus 1 dt is half multiplied by 2 log of mod of t plus 2 minus half of log of, we had a half over here, I just forgot this half over here, we have a half over here, this was half, so half of, we just multiply with the half, so we have half, this thing is just simply, oh, that's very easy. So this is basically half of log of mod of t plus 1 plus c. So now 2 gets cancelled. We have log of x square plus 2 minus half log of log mod of x square plus 1 plus c. That's the answer. Half log of x square plus 1. Sorry, half log of, we had log of x square plus 2. What we have? We have log of x square plus 2 minus half log of x square plus 1. So x square plus 2 minus half log of x square plus 1 plus c. Option A is the right answer. Let us move on to the next problem. We have integration of dx upon x into x to the power of 5 plus 3. So this is integration of x to the power of 4. Now what we can do is, we can multiply with x to the power of 4 over here, and we can make this x to the power of 5, x to the power of 5 plus 3. So what we are doing, we are multiplying with the x to the power of 4 in the numerator and the denominator to make this x to the power of 5. And why we are doing so? Because we can now we can take the substitution x to the power of 5 as t, which is 5 into x to the power of 4 dx is dt, which is just simply x to the power of 4 dx is dt upon 5. So we can easily take this substitution. So this is integration of, now x to the power of 4 dx, 5 into x to the power of 4 dx is dt, x to the power 4 dx is obviously dt upon 5. So 1 by 5 is just a constant. So we have uh, 1 by t into t plus 3 into dt. Now we just don't need to take a partial fraction for this, like a by t and then b by plus b by t plus 3. No need to know this. Like, these are basically observation problems. You have to observe these. You have to observe that function, and you have to decide how to represent this in terms of partial fraction. Like here, if you see, we have 1 by 5, and we can write this as, let's see here, we can write this as 1 by 3 multiplied by 1 by t minus 1 by t plus 3. If you see, I have already adjusted this. See, t plus 3 minus t, so t gets cancelled, and you have extra 3 over here. For that, I have taken an 1 by 3 over here. There will be an extra 3 in the numerator, so that's why I have taken an extra 1 by 3 over here. So we have 1 by 15. Now this is integration 1 by t minus 1 by t plus 3 dt. So this is 1 by 15. Now we have log of mod of t minus 1 by 15 log of mod of t plus 3 plus c. So what was t? T was x to the power 5. So we have 1 by 15 into log of x to the power 5 minus 1 by 15 into log of x to the power 5 plus 3. See what we can write this from here. So if we take 1 by 15 common, so we can write this log of x to the power 5 by x to the power 5 plus 3 plus c. So this is log of 1 by 15 x to the power 5. Oh, sorry, this is option. This is option B, not A. 1 by 15 log of mod of x to the power 5 divided by x to the power 5 plus 3 plus c. Now let's see some of the special cases of partial fraction. I am going to explain the special cases. Let's see the first special case. The first special case says that whenever there are even powers of x in both the numerator and the denominator, like for example, if I say here you have x squared divided by x squared plus 2 and x squared plus 3. In this case, you can simply put, yeah, they have asked to find the integration of this. Now in this case, you can simply put x square as t, simply put x square as t, or x square as y, simply put x square, don't take t, since uh, you can take t, but we have already used t for substitution, or we will be using t for substitution here. So let's take this x square as y, and you can simply put this as, and while you do the partial fraction process, you can simply replace the value of x square by y plus 2 and y plus 3, and use this to, now this will be a by y plus 2 plus b by y plus 3, and then the rest of the process will be the same. And after calculating whatever will be the value, so you have to simply again replace the value of y by x square. We already assume the value of x square as y. So now after calculating this one, we have to again replace the value of y by x square, and then we have to simply integrate with respect to x. That's all. This was one case. The second case is evaluation of the integrals of the form integration x square plus a divided by x to the power 4 plus lambda x square plus a square dx, or integration x square minus a divided by x to the power 4 plus lambda x square plus a square dx. So here capital A is greater than 0 and k is a real number. So let's see. In both the cases, if I say, you have to say, I'll just take the first case. You have to the first step will be, you have to divide the numerator and the denominator by x square. So then this will be 1 plus 1 by a by x square divided by, this will be if you just, this will be x square plus lambda plus a square by x square. So you have to divide this first, and then you have to take some of the substitution and you have to calculate. Like if you see here, we can easily, if you see the numerator, if you observe the numerator is 1 plus a by x square. So we can take the substitution as x minus a by x as t. Now if you take this substitution, so this will be 1 minus, so 1 plus a by x square dx is dt. So which is the numerator? So this is the dx is dt. And regarding the denominator, if you see x square plus a square by x square. Now if you, from here, if we square both sides, so this will be a square minus a square minus 2ab plus b square equals to t square. Now this is, if you see here, x gets cancelled over here. You are only, we can easily find the value of x square plus a square from here, a square by x square, which is t square plus 2a. We can simply write this as integration 1 plus, okay, this is 1 plus a by x square is now dt. So dt upon, and we have x square plus a square by x square is t square plus 2a, and we have lambda over here. So, and similarly we have to evaluate the second one as well, which means this one. So x square minus a by, the second form says that integration x square minus a divided by x to the power 4 plus kx square plus a square dx. Now this is very easy. Just over here again you have to do the step 1. Step 1 is to divide this. Step 1 here you have to divide the whole equation, the whole function, in the numerator as well as in the denominator. You have to divide by x square. So this will be 1 minus a by x square divided by x square plus, this was lambda, then divided by lambda into, so x square by x square is just simply lambda again. So lambda plus again a square by x square. Now here what you have to do, here you have to take the substitution as x plus a by x as t. So this is 1 minus a by x square dx is dt. That's all. Now the similar process you have to do, the same process, after the same process you have to apply. You have to simply again square both sides, then you have to find the value of x square plus a square by x square. That's all. So based on these we will solve the next two problems. Oh, let's see this one. Integration of x square plus 1 divided by x to the power 4 plus x square plus 1 dx. So let us solve this one. Integration of x square plus 1 divided by x to the power 4 plus x square plus 1 dx. Let's see this one. So what is the first step? You have to divide this by x square. So 1 plus 1 by x square divided by, this is x square plus 1 by x square dx. Now we have to take what? We have to take the substitution as x minus 1 by x as t. If you see the new numerator, we have 1 plus 1 by x square. So if you just differentiate this one, this is 1 plus 1 by x square, dx is dt. And again, if you just square both sides from here, in this equation, if you square both sides, what happens here? If you square both sides, this is x square minus 2ab, so that's only 2, plus b square, x square 1 by x square is t square. So what is the value of x square plus 1 by x square? Is t square plus 2. So let's see, in this integral we have integration. Now let's see here, 1 plus 1 by x square, 1 plus 1 by x square dx is dt, divided by x square plus 1. Okay, so x square plus 1 by x square is what? T square plus 2, t square plus 2, and we have plus 1, so that's t square plus 3. So that's t square plus 3 dt. Now this is integration dt upon t square plus 3 dt. That's all. Now it is very easy to solve this one. What we have to do? This is 3 can be written as dt upon t square plus root 3 whole square dt. Now this is what? Tan inverse. We have to use the tan inverse formula. So this is 1 by root 3 tan inverse t by root 3 plus c. So now what we have to do? We have to simply replace the value of t by x minus 1 by x. So this is 1 by root 3 tan inverse of x minus 1 by x by root 3 plus c. So this is 1 by root 3 tan inverse of, if you further simplify this, this is x square minus 1 by root 3x plus c. So 1 by root 3 tan inverse of x square minus 1. Option A is the right answer. Okay, the last problem of our lecture. So let's do the last problem of our lecture. So here I is integration of e to the power x divided by e to the power 4x plus e to the power 2x plus 1 dx, and j is integral of e to the power minus x divided by e to the power minus 4x plus e to the power minus 2x plus 1. What is the value of j minus I? So we have to calculate the j minus I, value of j minus I. So let's see. So let us write down j minus I. Let's do the solution. Integration. J minus I we have to do. So j minus I is just simply e to the power. Let's see what is j minus I. This is e to the power. Okay, this is e to the power. Alright. This is e to the power x. And this is e to the power 4x plus. Okay. So there is some specific trick in order to solve this problem. We just can't easily simplify in order to, like, we have to bring this into the form of like, we have to you can easily observe that we have to simplify, you know? So e to the power minus 3 minus x is there in the j, and we have in the denominator we have e to the power minus 4x, and what else, e to the power minus 4x and plus e to the power minus 2x plus 1. What we can do? So is, you know that we have to make the denominator first in order to do this one. So how to make the denominator equal? This is the main thing. How to make the denominator equal? So j. So what should we multiply in the numerator and the denominator? So carefully watch this step. So j minus I, we have to find j minus I in integration of this. So e to the power minus x divided by e to the power minus 4x plus e to the power minus 2x plus 1. Let this be the same. This I should be the same, and we are whatever changes we have to do, we have to make this in j. E to the power minus x divided by e to the power minus 4x plus e to the power minus 2x plus 1. Okay, so we have to make the denominator and the numerator e to the power 4x. So what shall we do? What shall we multiply? So this is what we have to do is we can write this as e to the power 3x divided by e to the power 4x. This j e to the power 4x now, and this is e to the power 2x plus 1, and then minus I is the same thing, so I e to the power x by e to the power 4x plus e to the power 2x plus 1 dx, the whole dx. We have to find the value of j minus I. We got the value of e to the power minus x divided by e to the power minus 4x plus e to the power minus 2x plus 1. So we have simplified this. Why? Just to make the denominator equal, so it is easier for us, it is better for us to calculate now. So this is e to the power, we can easily write this e to the power, we can take e to the power x common and write this e to the power 2x minus 1 divided by the denominator is just now the common, so this is e to the power 2x plus 1 d of x. Now we can take the substitution e to the power x, that's t, so this is e to the power x dx is dt. So this is, now let's see, this is t square minus 1 divided by e to the power, sorry, t to the power 4 plus t square plus 1 dt. This is integration of t square minus 1 is what? Now this is very easy. We have just done a similar problem to this. Okay, so let's try out this one. This is t square minus 1. So first is we have to divide this by t square. So 1 minus 1 by t square divided by t square plus 1 by 1 plus 1 by t square dt. Now what we have to take? We have to again take a substitution, which is t plus 1 by t as z. So this is 1 minus 1 by t square dt is dz. So this is dz upon, now once again you have to square both sides, so this is t square plus 2 plus 1 by t square is z square. So what is the value of t square plus 1 by t square? It's z square plus 2. So let's see here, so this is t square, so t square plus 1 by t square is z square plus 2, so plus 1. This was z square plus 2, so this is basically, okay, sorry, this was is this the right one? Okay, yeah, so t square plus 2 plus 1 by t square is z square. I just squared both sides. Now this became 1 minus 1 by t square. That's all. So t square plus 1 by t square is z square. This was minus 2. Yeah, there. This was minus 2. Z square minus 2. This is z square minus 2. So basically, t square plus 1 by t square is z square minus 2. Z square minus 2 plus 1. So this is integration dz divided by z square minus 1. What is this? This is log of, very easy, log of, now do we have anything? Okay, there was 1 by 2 outside. 1 by 2 into 1. Log of mod of z minus 1 divided by z plus 1 plus c. Now what we have to do? We have to now simply replace the value of z by t plus 1 by t, and then again replace the value of t by e to the power x and after that you will get your answer as C. You have to adjust and write it. Okay. So, but what you have to do in the last step? You have to simply replace the value of z by t plus 1 by t. Then again, after that, we have to replace the value of t by e to the power x over here. You have to replace back all the values. Then you will get the answer as C. Thank you. This was our last problem. So if you like the video, then please share, subscribe, like it. See you in my next video. And of course, if you want a video on some specific topics, then please write it down in the comment section below. I will surely try to make one. So thank you for now. See you all in my next video.